Hello, I'm Andrew Lash, and I will be taking you through this next lesson on the OWASP AI Exchange. In this lesson, we'll explore the development time threats chapter of the AI Exchange and recommended controls. You'll learn Introduction to Development Time Threats, Broad Model Poisoning Development Time, and Sensitive Data Leak Development Time. A link to the Development Time Threats webpage is shown on the slide here at https://owaspai.org/docs/3_development_time_threats. Let's move into the first section, which covers the introduction to development time threats. Development time threats target the AI system while it's being built, particularly data, code, and model components. Since this stage handles real and often sensitive data, it requires strong security measures. The development phase exposes valuable assets to risks like data poisoning, leakage, and manipulation. Compromised training data or model code can permanently degrade system integrity. The benefits are that it protects sensitive training data and intellectual property, prevents poisoned models and corrupted outputs, and strengthens the trustworthiness of deployed AI systems. Best practices include implementing secure development environments, using data provenance checks, and monitoring for anomalies in training data. Include AI-specific threats and risk management processes, and ensure supply chain integrity for data and models. Securing AI begins long before deployment. Safeguarding development time processes ensures integrity, reliability, and compliance from the start. The controls for development time protection include the general controls from the AI Exchange, and the following controls, each marked with a hash and a short name in capitals. Hash depth security. Development security ensures that sensitive AI development assets like training data, model parameters, and configurations are properly protected within secure environments and processes. Why does this matter? AI development environments handle highly sensitive data and intellectual property. Weak security here can lead to data leaks, poisoning, or model theft, undermining the entire AI lifecycle. Benefits include protecting confidentiality of data and IP, ensuring the integrity of models and code, and supporting regulatory compliance and trust. Best practices include the following. 1. Use encryption at rest, least privileged access, and segregated environments. 2. Implement integrity checks via signing, hashing, and continuous monitoring. 3. Audit dependencies and supply chain components for authenticity. And 4. Monitor for suspicious activities with logging and runtime checks. Robust development security forms the backbone of trustworthy AI. Safeguarding assets early prevents downstream risks across the entire AI lifecycle. Hash segregate data. Segregating AI development data ensures sensitive assets like training data, test data, and model parameters are stored in dedicated, access-controlled environments to reduce risk. Why does this matter? AI development environments contain the most sensitive and valuable data. Without separation, a single compromise could expose entire data sets or models, leading to data leaks or model poisoning. The benefits are it reduces attack surface and insider risk, it enables targeted hardening of critical areas, and it enhances compliance and auditability. Best practices are as follows. 1. Create distinct environments, for example, data engineering, training, testing. 2. Use role-based access and strict data handling policies. 3. Apply encryption and logging per environment. And 4. Periodically review segregation boundaries to ensure they align with AI workflows. Data segregation strengthens AI resilience by ensuring that only those who truly need access to sensitive assets can reach them, protecting integrity, confidentiality, and overall system trustworthiness. Hash compute. Confidential computing leverages specialized hardware environments like trusted execution environments or TEEs to protect AI data and models during use, not just at rest or in transit. Why does this matter? Traditional encryption stops once data is processed. Confidential compute ensures sensitive training data and model parameters remain protected even during runtime, reducing insider and supply chain risks. The benefits are that it prevents data exposure during training or inference, it protects intellectual property and model weights, and it enables secure multi-party collaboration on shared data. Best practices are as follows. 1. Implement hardware-backed TEEs, for example, Intel SGX, AMD SEV, Azure Confidential VMs. 2. Ensure data and model encryption extend through all lifecycle stages. And 3. Combine with access control and monitoring for full protection. Confidential computing adds a powerful layer of runtime protection, ensuring that even privileged insiders cannot access sensitive AI data while it's being processed. Federated learning. Federated learning is a decentralized approach where multiple clients train AI models locally and share updates, not raw data, with a central server. This reduces data exposure while maintaining model performance. Why does this matter? By keeping data on local devices or within organizations, federated learning enhances privacy, regulatory compliance, and data diversity, especially for sensitive domains like healthcare or finance. Benefits of this are: it supports data sovereignty and cross-border compliance, it reduces bandwidth and storage costs, increases model diversity and robustness through varied local data, and it minimizes centralized data breach risks. Best practices are as follows. 1. Protect model transfer channels using encryption. 2. Implement secure aggregation and client authentication. 3. Monitor for poisoned updates or malicious participants. And 4. Combine with confidential compute or secure multi-party computation, or SMPC, for enhanced protection. Federated learning enables collaborative AI innovation without compromising privacy, but demands robust controls to prevent poisoning, data leakage, and model theft across distributed systems. Supply chain manage. AI supply chain management extends beyond software dependencies to include data and models, which can introduce hidden vulnerabilities or manipulations. Managing these risks ensures trustworthy, resilient AI systems. Why does this matter? AI ecosystems rely on numerous third-party elements including datasets, pre-trained models, and libraries. Each adds risk of poisoning, malware, or intellectual property theft, making strong supplier oversight essential. Benefits of this are that it improves transparency and accountability across model lineage, it enables rapid response to discovered vulnerabilities, and it builds trust and compliance through documented provenance. Best practices are as follows. 1. Verify source authenticity and perform supplier audits. 2. Use AI bill of materials or AI bomb or model bomb or MBOM for full traceability. 3. Regularly scan dependencies, patch and check integrity. 4. Protect development environments that execute third-party components. And 5. Combine with data provenance frameworks, for example ISO/IEC AWI 5181. A secure AI supply chain requires visibility from data origin to deployment, ensuring every model, dataset, and dependency is verified, traceable, and tamper-free. Broad model poisoning refers to intentional manipulation of data, code, or models during development to compromise AI integrity. It's one of the most critical threats to trustworthy AI. Why does this matter? Such manipulation can undermine fraud detection, cause safety failures, or damage reputations, making integrity protection essential throughout the AI lifecycle. Benefits of understanding include enabling teams to design preventive controls at multiple layers, improving threat visibility across data and model pipelines, and supporting accountability and model provenance tracking. Best practices are as follows. 1. Segregate development environments to isolate sensitive stages. 2. Validate and monitor data sources, configurations, and model parameters. 3. Apply integrity checks, supply chain verification, and continuous validation. And 4. Educate developers about poisoning indicators and prevention methods. Model poisoning can occur anywhere in the AI pipeline, from data to deployment. Robust validation, monitoring, and supply chain governance are key to maintaining trustworthy AI behavior. Controls for broad model poisoning include the following. The general controls of the AI exchange, especially limiting the effect of unwanted behavior. Controls for development time protection. Controls specific to data poisoning and development time model poisoning. And the following controls, each marked with a hash and short name in capitals. Model ensemble. A model ensemble combines outputs from multiple independently trained models to improve reliability and detect tampering. It's an effective defense against data poisoning and training anomalies. Why does this matter? When one model produces an outlier result, it signals possible data corruption or adversarial interference. Ensemble systems act as a built-in integrity check and enhance robustness. The benefits of this are it improves detection of poisoning or mislabeling, it provides fault tolerance against single model failure, and it increases accuracy and confidence through consensus. Best practices are as follows. 1. Randomly split training data among ensemble members. 2. Compare outputs to detect discrepancies or drift. 3. Use weighted voting or averaging to combine results. And 4. Periodically retrain and validate ensemble components. Model ensembles strengthen AI reliability by leveraging diversity. Discrepancies between models can reveal poisoning attempts or data quality issues early. Data poisoning, also called causative attacks, is when an adversary tampers with any data the model learns from, training sets, supplier datasets, or data used for retrieval or in-context prompts, so the model produces incorrect or malicious outputs. Why does this matter? Poisoned data can undermine model integrity, causing wrong decisions, safety failures, fraud bypasses, or reputational and legal harm. Backdoors are especially dangerous because they stay hidden until triggered. The benefits of addressing this are that it preserves model reliability and trustworthiness, it reduces risk of targeted malicious outcomes like safety, fraud, privacy breaches, and it improves incident response through clearer provenance and auditing. Best practices are as follows. 1. Enforce data provenance and supplier vetting, like hashes, attestations, and AI bomb. 2. Segregate environments, ingest, pre-processing, training, and apply least access. 3. Implement integrity checks, like hashing or signatures, on datasets and model artifacts. 4. Use data validation and anomaly detection to find suspicious samples early. 5. Employ ensemble methods, adversarial training, and diverse test sets to detect or mitigate poisoning effects. 6. Run red team tests and include backdoor or trigger scenarios in the test suites. And 7. Monitor production inputs for abnormal patterns that might feed training pipelines. Treat training data as a critical asset. Verify origin, lock down access, and test proactively, because once a model learns poisoned data, fixing the damage can be costly and difficult. Controls for data poisoning include the following. General controls from the AI exchange, especially limiting the effect of unwanted behavior. Controls for development time protection of primarily the training data. Controls for broad model poisoning. And the following controls, each marked with a hash and short name in capitals. Hash more trained data. Adding more trustworthy data during training dilutes the effect of poisoned samples. The more diverse, clean examples the model sees, the harder it is for poisoned data to alter behavior. Why does this matter? Attackers rely on small sets of malicious inputs. A large volume of verified data can effectively drown out those manipulations, improving generalization and reliability. The benefits of this are it reduces the statistical impact of poisoned or biased samples, it improves robustness and generalization of model performance, it enhances model fairness and stability over time. Best practices include 1. Use data augmentation to generate synthetic but valid variations. 2. Prioritize data diversity from multiple trustworthy sources. 3. Validate and deduplicate data to avoid replicating bad inputs. And 4. Revisit older models with fine-tuning on clean data. Hash data quality control. Data quality control ensures AI models train on clean, accurate, and trustworthy data. For AI, this extends beyond traditional quality checks. It includes defenses against malicious data manipulation that can corrupt model behavior. Why does this matter? Poisoned or poor quality data can mislead models, creating long-term vulnerabilities or performance failures. Preventing this at training time is far easier than fixing it later. The benefits of this are that it enhances model reliability and security. It detects malicious data tampering and unintentional errors, and it builds trust in model outputs through verified data integrity. Best practices include the following. 1. Use secure hash verification to detect data tampering. 2. Apply statistical anomaly and pattern analysis for deviations. 3. Combine automated scanning with human validation for critical inputs. 4. Regularly audit datasets and update detection criteria. And 5. Follow ISO/IEC 5259 and 42001 guidelines while supplementing with security-focused checks. Strong data quality control is the foundation of trustworthy AI. Detect anomalies early, verify integrity often, and continuously adapt your checks to evolving threats. Train data distortion. Train data distortion protects models by altering input data, adding noise or smoothing to make hidden poisoned patterns ineffective. It prevents the model from learning attacker-inserted triggers that could later cause harmful outputs. Why does this matter? Backdoors and poisoned data can silently compromise a model's integrity. Distorting training data helps neutralize these triggers and enhances model robustness without removing useful information. The benefits of this are that it reduces the model's sensitivity to malicious patterns. It supports privacy protection through data minimization and differential privacy, and it improves overall model generalization and resistance to poisoning. Best practices are as follows. 1. Apply controlled noise or smoothing only during training. 2. Retain original datasets for calibration and testing distortion levels. 3. Train in a trusted, isolated environment to prevent reinjection of poisoned data. 4. Combine with complementary techniques, adversarial training, ensemble methods, or differential privacy. And 5. Experiment with ANISA recommended defenses, such as defense-GAN, trim, or strip. Distorting training data transforms malicious precision into harmless noise, a practical proactive safeguard to build resilient and trustworthy AI systems. Poison robust model. A poison robust model is one that resists malicious data patterns or backdoors learnt during training. This control focuses on post-training mitigation, cleaning or restructuring the model to remove harmful learnt behavior. Why does this matter? Even trusted models can be compromised if poison data was unknowingly included in training. Post-training defenses allow organizations to safely use externally sourced or legacy models without full retraining. The benefits of this are that it removes backdoor triggers while preserving core performance. It enables recovery of models trained on contaminated data, and it reduces dependency on retraining from scratch. Best practices are as follows. 1. Pruning to identify and remove non-essential or suspicious neurons. 2. Fine-tuning to retrain on a clean dataset to overwrite poison patterns. 3. Combine both in fine pruning for stronger protection. 4. Continuously validate output behavior after modification. And 5. Keep version control and audit logs for traceability. Poison robust modeling restores trust in AI systems by cleaning their learnt behaviors, an essential safeguard when reusing or acquiring pre-trained models. Train adversarial. Adversarial training strengthens models by including deliberately perturbed or manipulated samples during training. These examples simulate evasion or poisoning attempts, teaching the model to correctly classify inputs even when they are subtly altered. Why does this matter? Small, targeted changes to input data can fool AI systems, especially in safety-critical cases like autonomous vehicles or fraud detection. Adversarial training helps the model generalize beyond clean examples and resist manipulation. The benefits of this are that it increases robustness to adversarial and poison inputs. It reduces the risk of evasion by minor data perturbations, and it improves trust and reliability in operational environments. Best practices are as follows. 1. Incorporate adversarial samples during training to harden models. 2. Regularly update adversarial sets to match evolving attack methods. 3. Validate model accuracy post-training to ensure performance stability. And 4. combined with other defenses, for example, evasion, robust models, and data distortion. Adversarial training equips models with immune responses to manipulation, essential for resilient AI systems exposed to hostile or dynamic environments. Development environment model poisoning targets the model creation process itself. Attackers manipulate model parameters, training scripts, or configuration files instead of data. This changes model behavior at its core, often without visible data tampering. Why does this matter? Unlike data poisoning, this attack corrupts the model from within its own environment, making it hard to detect and potentially compromising all future outputs. It also undermines trust in the development pipeline. Benefits of awareness and mitigation are that it protects model integrity and intellectual property, it prevents backdoors or hidden manipulations in model weights, and it ensures secure, reproducible builds. Best practices are as follows. 1. Secure development environments. See the Dev security control. 2. Apply access control, integrity checks, and environment segregation. 3. Verify model provenance, such as signing and version tracking. And 4. Include supply chain assurance and dependency validation. Protecting the AI development environment is as vital as securing training data. A single compromised parameter file can poison an entire model. The controls for development environment model poisoning are as follows. General controls from the AI exchange, especially limiting the effect of unwanted behavior. The controls for development time protection. See the controls for broad model poisoning. Controls that are aimed to improve the generalization ability of the model, reducing the memorization of any poison samples, include training with adversarial samples and adversarial robust distillation. Supply chain model poisoning happens when a pre-trained or open source model is compromised before being integrated or fine-tuned. The model's parameters or training data may have been manipulated, embedding unwanted behaviors that persist through later use. Why does this matter? Modern AI pipelines often rely on third-party models to save time and cost. However, if these models are poisoned, the resulting AI system inherits hidden vulnerabilities or malicious logic, even after additional fine-tuning. Benefits of awareness and mitigation are that it protects against transfer learning attacks and inherited backdoors. It ensures integrity and reliability of externally sourced models, and it supports compliance and traceability in AI supply chains. Best practices are as follows. 1. Implement supply chain management controls, such as the hash supply chain managed control of the AI exchange. 2. Verify model provenance and integrity, such as signatures, hashes, and certificates. 3. Use model ensemble or poison robust models for validation. 4. Prefer reputable, auditable sources for pre-trained models. And 5. Continuously monitor model performance for anomalies after integration. Supply chain model poisoning is a silent threat. Securing AI means securing every model you inherit. Always verify, validate, and document before trusting third-party intelligence. Controls for supply chain model poisoning include the following. General controls, especially limiting the effect of unwanted behavior from the AI exchange. See those controls for data poisoning that work on models that have already been trained, post-training, for example, poison robust model. See hash supply chain managed to control obtaining a reliable model from a reliable supplier. Other controls need to be applied by the supplier of the model. For example, controls for development time protection, like, for example, protecting the training set database against data poisoning, controls for broad model poisoning, and controls for data poisoning that work pre-training. Development time data leaks occur when sensitive training or test data, often containing personal or proprietary information, is exposed from insecure AI development environments. Engineers frequently handle real data, making these environments high-value targets. Why does this matter? Such leaks compromise privacy, intellectual property, and trust. When AI models are trained or fine-tuned in cloud environments, the data in transit or at rest can be intercepted or mishandled, amplifying exposure risk. Benefits of awareness and mitigation are that it preserves data confidentiality and compliance, for example GDPR or the New Zealand Privacy Act. It prevents leaks of intellectual property or personal data, and it strengthens trust in AI lifecycle management. Best practices are as follows. 1. Apply development environment security controls, for example #devsecurity control from AI Exchange. 2. Encrypt data at rest and in transit. 3. Use access controls, monitoring in segregated environments. 4. Vet and secure cloud and third-party training platforms. And 5. Conduct regular audits for data movement and storage. AI models are only as secure as the data they're trained on. Protect development environments like production systems to prevent data leaks before they occur. Controls for development time data leak include the following. General controls from the AI Exchange, especially sensitive data limitation, and controls for development time protection. Model theft through parameter leakage occurs when attackers gain unauthorized access to a model's internal parameters during development. These parameters represent the model's intellectual DNA, enabling adversaries to replicate the model, conduct targeted attacks, or uncover its vulnerabilities. Why does this matter? A stolen model allows attackers to perform adversarial testing, evasion, or inversion attacks without restrictions such as rate limits or access controls. Beyond operational risks, the theft also causes loss of competitive advantage and intellectual property exposure. Benefits of awareness and mitigation are that it preserves intellectual property and proprietary innovation, it reduces risk of model misuse or cloning by adversaries, and it strengthens overall AI lifecycle confidentiality. Best practices are as follows. 1. Secure the development environment. 2. Implement encryption, least privilege access and network segmentation. 3. Use model signing and integrity verification mechanisms. 4. Monitor for unauthorized exfiltration of model artifacts. And 5. Avoid storing sensitive parameters in shared or cloud environments without strong isolation. Protecting model parameters is protecting your AI's core value. A leak in development can hand your model and its weaknesses directly to an attacker. Controls for model theft through development time model parameter leak include the following. General controls from the AI Exchange, especially sensitive data limitation, and controls for development time protection. Source code and configuration leaks occur when attackers gain unauthorized access to the scripts, configurations, or settings that define how AI models are built and trained. These components reveal sensitive intellectual property and model logic. Why does this matter? Exposed code or configuration can allow attackers to replicate your models, identify vulnerabilities in pre-processing or training, or inject malicious modifications. Such leaks threaten both competitive advantage and system security. Benefits of awareness and mitigation are that it preserves intellectual property and proprietary algorithms, it reduces attack surface for model manipulation or replication, and it builds trust and compliance through secure engineering practice. Best practices are as follows. 1. Implement DevSecOps principles with strict access management. 2. Encrypt repositories and segregate sensitive assets. 3. Monitor for unusual data exfiltration or repo access. 4. Use secure version control, code signing, and audit logging. And 5. Regularly review configurations for exposed secrets or keys. Your model's blueprint is its code and configuration. Protect them as rigorously as the data itself to prevent intellectual theft or compromise. Controls for source code or configuration leak are as follows. General controls from the AI Exchange, especially sensitive data limitation, and controls for development time protection. This concludes the lesson on development time threats and associated controls that form part of the OWASP AI Exchange. I hope you will join me in the next lesson, which covers runtime application security threats. Goodbye.